Okay, we will solve problem 3.40 from Sadiku book. So the question is find I0 using mesh analysis, and I0 is here, and this is actually a famous circuit there. It's called Whetstone Bridge, and you can find out about it, but we will use simple mesh analysis to solve this. So let's just start with drawing the loops, as we are asked to use mesh analysis. So let's start by making a loop, because the direction of the current that we are asked for is to the right. So I will make the loop like this, so we don't need to put negative sign later. So let's call this loop 1, and okay, this one is loop 2, and this one is loop 3. Okay, let's start at loop 1. At loop 1, as usual, if we have a loop, we apply KVL, or the sum of the voltage in a loop is equal to 0. So I will have this voltage source here. It's flowing from negative to positive, so the sign is negative, so it's minus 64. And let's move on to that resistance here. It's 2 kilo ohm plus 2, but it is a resistance, so we need to multiply it by the current. So the current that passed through here is only I1. So let's write it. Remember that the unit is kilo ohm, so the unit of the current should be in milliampere. And let's move on into the 6 kilo ohm resistance. So it's 6 kilo ohm, and we need to convert it to voltage by multiplying it with the current that passed through it. So it is I1 minus I3, not I3, I2 minus I2. And the last one is this resistance, the 4 kilo ohm one. So it's 4, and the current that passed through it is I1 and minus I3 on the opposite direction, and that will equal to 0. Let's move this minus 56 to the right hand side, so we'll have 2 I1 plus, let's multiply this, 6 I1 minus 6 I2 plus 4 I1 minus 4 I3, and that will equal to 56. Okay, now we will have 2 plus 6 plus 4, and that will equal to 2 plus 6 plus 4, 12. 12 I1 minus 6 I2 and minus 4 I3 is equal to 56. And I will just leave this as equation number 1. Okay, let's move on to the loop number 2. And again, we apply KVL, Kirchhoff voltage law. I don't know how to pronounce Kirchhoff correctly, but yeah, I tried my best. So the sum of the voltage is equal to 0 in a loop. And let's start using this resistance here. So it's 6 kilo ohm, 6 kilo ohm, but we need to convert it to the voltage, so we multiply it by the current, because it's loop 2, so we focus on this loop. So I2 come first, and in the opposite direction is minus I1, and then let's move on to this resistance. It's 6 kilo ohm. So again we have 6. The only current that pass through it is I2, and the last one is this 2 kilo ohm resistance 2. So we need to convert it to voltage by multiplying it with the current. So I2 is going there, and I3 is going to the opposite direction, and that will equal to 0. Now we multiply it to remove the brackets. Plus 2I2 minus 2I3, and that will equal to 0. And this one is 12 plus 2, it's 14. Okay, so I will have minus 6I1 plus 14I2 minus 2I3, and that will equal to 0. Let's save this as equation number 2. And now we move on to loop number 3. And we do similar things as before. KVL, and the sum of voltage in a loop is equal to 0. Now let's start at this resistance here, the 4 kilo ohm one. So I will have 4, and we focus on loop 3, so I3, and the current that goes in opposite direction is I1. Okay, my 3 look bad, so okay, and then we move to this resistance here, plus 2, and we focus on I3, and going to the opposite direction is I2, and then plus this 4 kilo ohm resistance, and the only current that pass through it is I3. So that will equal to 0, and let's multiply this to open the brackets. Minus 4I1 plus 2I3 minus 2I2 plus 4I3, and that will equal to 0. For I1 I will have minus 4I1, and for I2 I will have minus 2I2, and then we'll have for I3, 4 plus 2 is 6, 6 plus 4 it's 10, 10 I3, it's equal to 0, and let's save this. And okay, let's save the equations here. We'll have 1, 2, and 3, and let's save these 3 equations and erase the right hand side of the board. We'll have for equation number 1, it's 12I1 minus 6I2 minus 4I3, it's equal to 56. And equation number 2, it is minus 6I1 plus 14I2 minus 2I3 is equal to 0. And for equation number 3, it is minus 4I1 minus 2I2 plus 10i3 it's equal to 0. So let's erase this because we saved the equations. So what we need is find I0 or I1 in this case. So let's solve it by eliminations. And what was the easiest thing to do here? I think I will use the equation 1 and equation 2. So I will use the equation 1 and I will multiply it by 1, and the equation 2 I will multiply it by 2, and let's write it. So the equation 1 is 12i1 minus 6i2 minus 4i3, and that will equal to 56. Equation number 2 we multiplied by 2, so I will have minus 12i1 plus 28i2 and minus 4i3. Now we'll have that equal to 0, and I will eliminate this I1 by add those two equations. So I will have, this one is 22i2 minus 8i3, and that will equal to 56. And now let's save this as equation number 4. Now I will use equation number 1 again, multiplied by 1, and I will have equation number 3 multiplied by 3. So I will eliminate this I1, so I will have 12i1 minus 6i2 minus 4i3, it's equal to 56, and this one is minus 12i1 minus 2 times 3 is minus 6i2 and plus 30i3, and that will equal to 0. Okay, let's add that, and I will have minus 12i2 plus 26i3, and that will equal to 56. Okay, and let's save this as equation number 5. Okay, now I have equation number 4 and equation number 5, and what can we do here? It's 8. Oh, so okay, let's just do question number 4 times 6. Okay, it is, and equation number 5 times 11. Okay, and I will have 22 times 6 is 132 I2 minus 48 I3, and it will equal to 56 times 6. Okay, just leave it alone. I will resolve that later. And this one, minus 12 I2, it will be minus 132 I2, and then plus 286 I3, and it will equal to 56 times 11. So let's add, and this will be cancelled, and what's that? 200, and it's 8 3. Okay, 238 I3, and that will equal to 56 times 11. So I will have I3 will equal to 56 times 11 divided by 238, and that will equal to, finally I have to use calculator. And that will equal to 4 milliampere. Okay, now let's substitute this 4 to these equations 5. So let's use that equation. So I will have minus 12 I2 plus 26 I3 is 4, and that will equal to 56, and I will have minus 12 I2 is equal to 56 minus this 26 times 4 is 104, and minus 12 I2 is, what is it, 56 minus 104, it is minus 48, and again I2, I got I2, it's 4 milliampere, and finally we can substitute I3 and I2 to one of these equations. So let's erase this first. So I2 and I3 is 4 milliampere. So I will have this one, 12 I1 minus 6 I2 is 4, and minus 4 I3 is 4, and that will equal to 56, and I will have 12 I1 minus 24 minus 16 is equal to 56, and 12 I1 minus 40, it's equal to 56, and 12 I1 is equal to 96, and I1 is equal to 8 milliampere. And remember that we are asked to find I0, so I0 is equal to I1, so it is 8 milliampere. And here is the final answer. Hope that I don't make any mistakes, and thanks for watching.